Okay, so this is the 2015 DEB mock exam question B1. So the horizontal and vertical coordinates for planes ABC, planes ABC and ABD are given. Okay, on the panelists presenter's desk. Draw the plan and elevation of the planes. All right, so the x coordinate is how far from the end vertical plane. So basically, if you draw a vertical line, how far you measure across. Okay, so it's how far from the end vertical plane. So I'm marking 30 for A, 40 for B, 120 for C. Okay, and then D is 65. Now, the y coordinate is how far up from the horizontal plane you're going. So, oh, damn it. The xy line is a HP in elevation. So, it's how far up we're going here. So, A is up 50. So, that's point A. Then B is on the xy line. C is up 50. And then D is on the XY line as well. Alright, then the Z coordinate is how far down from the out from the vertical plane you're going. So the vertical plane is the XY line in plan, so it's how far from the XY line in plan you're going. So for A, it's 25. B is 60. C is 75. Point C, and then D is 20. Right, so A joins to B and B joins to D, or sorry, A joins to B, B joins to C, and C joins back to A. Then A joins to B, B joins to D, and D joins back to A. So then the plan view, A to B, B to C, C to A, and then D to B, and D to A. And D to A. Right, so we've defined the dihedral angle between the two planes. So the line of intersection is AB. Okay, so we're going to check if line AB is a true length. Already, it's not. So we're going to look perpendicular to line AB, and then we're going to get it as a true length, then look along it, and we're going to see it as a point. So there we go. Right, so I'm just going to pause this and extend all these lines. Before I do that, I'll draw in my x1, y1 line. That's parallel to line AB and perpendicular to the projection lines. Okay, so I'm going to pause the video and do that. So I have that done. Alright, so B is on the x1, y1 line. So there's B on the x1, y1 line. D is on the x1, y1 line as well. So there's D1. Then A and A is a height of 50. So I could use my compass or just get my set square. A is a height of 50. So there we go. And C is a height of 50. So I can mark them in. A1, C1. Right, so I can connect A to C, A1 to B1, B1 to C1, B1 to D1, and D1 to A1. Right, so here's the line of intersection as a true length. So we're going to look along our line of intersection now, because it'll appear as a point. And then I can draw in my x2, y2 line. Okay, and I can take the distances from the x1, y1 line back to plan. Now there's a lot of distance to make up there for my x1, y1 line. So I can just draw a line parallel to the x1, y1 line and call it the datum line. Now this just shortens the space I need to go back. So I'm going to put my compass on the datum line. So compass back to A, lift, find A here in my auxiliary elevation, mark it there. Okay, then B is the same, so B is there on the same point. D, take my compass there, bring it back to D, lift, find D1 here, mark it in there, and then C, take my compass, lift, find C here, and here's going to be the dihedral angle. So that's B2, A2, D2, C2. So we can join them together. There's the dihedral angle between the two surfaces. So you should get it, always measure that. Okay, and write it in. So just bear with me. So it's 75 degrees. Now the next one is determine the vertical and horizontal traces of plane ABC. Now the best way to do this is to find plane ABC as an edge. So it's where plane ABC intersects the vertical and horizontal plane. Now line AC is parallel to the XY line in elevation, so it's a true length in plan. Now if I want to see a surface as an edge, I need to look along the true length of a line on that surface. So if I look along line AC, okay, surface ABC appears as an edge. So I've looked along line ABC or AC, and I'm projecting from plan, so it's an auxiliary elevation. So the x1, y1 line will be an edge of the horizontal plane. So that'll be the HP there. Now, the altitude of the points A and C are an altitude 50. There's A and C. Now, point B is on the XY line. So there's B1. Now, so this is the HT. That's a point view of the HT. So this is the HT here. So that's the HT. Okay, now if I want to get the VT, alright, I'm going to have to extend on this line. Okay, extend out my x1, y1 line. Let's bring it across there. So that's T. Now, I'm going to draw a line parallel to the HT through point C, draw it until it hits the XY line. Okay, then I'm going to go straight up. I'm going to go parallel to the HT in elevation, which is just along AC. And then that's a point on the VT. So I can join these two together, and there's the V, there's the VT. That's part of it there. That's the HT there in plan, runs onto there, and the VT is running all the way down to here. So this now the next one is determine the inclination of plane ABC to the vertical plane. Now I love a question like that. So I need to see the vertical plane as an edge, and I need to see surface ABC as an edge. So I'd see the vertical plane as an edge in both the plan view and an auxiliary plan. Okay, and I want to get surface ABC to appear as an edge. So I'm going to draw a horizontal line in plan from point B. And the reason it's horizontal in plan, the reason it's parallel to the XY line in plan is because in elevation it will be a true length. So, and if you look along the true length of a line, the surface it rests on appears as an edge. So I'm going to look along surface, or the true length of the line on ABC. So there's an x1 and y1 line. It's an edge with a vertical plane because it's an auxiliary plan. I think I spelled that wrong, but however. Now we're going to put our compass on the XY line, and we're going to take our distances from the XY line down to plan. So there's point A, there's point B coming. Okay, this point here is the same as B, so I should call that, I'll call it M. So that's B1/M1, and then C, lift, find C here, mark C in, there's C1, out. So they all appear as an edge view. So there's the edge view with surface ABC. Oh, sorry, I went a little longer to there, and I can just extend that on and extend this on here, and this is the true angle of the surface to the vertical plane, the true inclination, which is 40 degrees, we'll say. True inclination to the vertical plane. And it also proves that the VT is in the right position, because as you extend the edge of the surface down until it hits the edge of the vertical plane, the point of the intersection is the VT, and look, the VT is parallel to line BM, so that proves that the VT is in the right position. Plane 2 VP. Right, that was a class question. Cheers, bye bye.